Tahmin Ano sa ulan? Good morning, Chairman, sir. Welcome to the program. We will start the program within shortly, within 10 minutes.
Hello. Good morning, sir. So I welcome our beloved chairman to the STTP program. I also welcome today's chief guest, Mr. Brijesh, to the program. So we will start our inaugural program within 10 minutes.
Hey Sharmila, Brijesh. Yeah, I can't hear you. I think you're on mute.
Sir, we will start session within 5 minutes.
Sure. Huh? Okay. Yeah, let me know.
Yeah, okay, I'll remind you, sir. Just tell me.
Sure. Yeah, I'll go on mute and stop the video.
Yes. Sir, Good morning, sir. Shall we start the program?
Yeah.
Good morning, sir. Chairman, sir. Good morning, sir. Hello. Good morning, sir. Chairman.
What is the program?
Yes, sir. Sir, shall we start the program? Sir, we will start the program.
Knowledge is gained with an open mind and thirst to learn. Success is backed by a strong determination, hard work, and a positive attitude. A very good morning to everyone present here. I, Ganesh Pai, Assistant Professor in Department of Computer Science and Engineering, welcome you all to the AICTE sponsored 6 days short-term training program on machine learning for societal applications, organized by Department of Computer Science and Engineering, PA College of Engineering, Bangalore. To begin with the function, we shall invoke the blessings of Almighty. I now request Professor Muhammad Saifuddin to invoke the blessings by reciting the verses of Quran.
أعوذ بالله من الشيطان الرجيم. I seek refuge with Allah from the rejected shaitan. Bismillahir Rahmanir Rahim. In the name of Allah, the most gracious, the most merciful. Alhamdulillahi Rabbil Alameen. All praises be to Allah, the Lord of the whole universe. Ar-Rahmanir Rahim. The most gracious, the most merciful. Maliki Yawmiddin. Master of the day of judgment. Iyyaka na'budu wa iyyaka nasta'in. You alone we worship and you alone we ask for help. Ihdina as-sirat wal-mustaqim. Lead us to the right path. Sirat wal-ladhina an'amta alayhim. The path of those upon whom you have bestowed your grace. غَيْرِ الْمَغْضُوبِ عَلَيْهِمْ. Not in the path of those who have earned your anger. وَلَا الضَّالِّينَ. And not in the path of those who went astray. Ameen. O Allah, please accept this dua.
Thank you, sir. I take this opportunity to welcome our delegates to the inaugural function of short-term training program. First and foremost, I would like to extend my hearty welcome to Colonel B. Venkat, Director, Faculty Development Cell, AICTE, New Delhi, to the inaugural ceremony of short-term training program. I, on behalf of everyone present here, wholeheartedly welcome the Honorable Chief Guest, Mr. Brijesh Balakrishnan, Senior Vice President and Unit Head, Digital Engineering Services, Director, the Board of Directors, CSS Corp Private Limited, India, to this function. I am honored to welcome the founder of PA Group of Institutions, Guest of Honor, and our Honorable Chairman, Dr. PA Ibrahim Haji, PA Education Trust, who has been our motivation for all the events organized in our institute and department. On behalf of all present here, I welcome you, sir.
Thank you.
It gives me immense pleasure to welcome our guest of honor, Mr. Abdullah Ibrahim, Executive Director, PA Education Trust, to this program in his absence, who has been encouraging us in all our activities in the institute. I extend a warm and cordial welcome to our Principal, Dr. Abdul Sharif, Vice Principal, Dr. Ramiz MK, Director Academics, Dr. Sarfraz Hashim, Principals from sister institutions, Director MBA, Heads of various departments, Staff Coordinators of STTP, faculty members of our department and institution, and all participants from various academic institutions and industries. It's my pleasure to welcome our resource persons of this short-term training program, Professor Ashok Rao, Professor and Director, NIE Mysore, Dr. P.S. Hiremat, Professor, KLE College of Engineering, Hubli, Dr. Zaid Ansari, Associate Professor, Aligarh Muslim University, Aligarh, Dr. P. Shivkumara, Professor, Department of Computer Science, University of Malaya, Malaysia, Dr. H.L. Shashireka, Professor, Mangalore University, Mangalore, Dr. Jnani Swaranath Satapathy, Professor, Department of Electronics and Communication Engineering, AJ Institute of Technology, Mangalore, Dr. Gangadhar Bhatt, Professor, Mangalore University, Mangalore, Dr. R. Dinesh, Research Scientist, Samsung R&D, Bangalore, Dr. B.H. Shekhar, Professor, Department of Studies and Research in Computer Science, Mangalore University, Mangalore, and Dr. S. Murali, Professor, Department of Computer Science and Engineering, Maharaja Institute of Technology, and President, Mahara Education Trust, Mysore, to this inaugural program. It is a true pleasure for me to welcome our beloved HOD and convener of STTP, Dr. Sharmila Kumari M, to this function. Madam, I request you to present a brief introduction of the short-term training program.
Thank you, sir. A very pleasant morning to all. Respected chief guest and inaugurator of this program, a dynamic technologist and business leader, Mr. Brijesh, guest of honor, Dr. P.A. Ibrahim Haji, our honorable chairman of PA Education Trust, Mr. Abdullah Ibrahim, beloved executive director, PA Education Trust, president of today's inaugural event, Dr. Abdul Sharif, the principal of our college, and vice principal, Dr. Ramiz MK, members of advisory committee, STTP coordinators, my fellow colleagues, and dear participants. I feel it is an honor and privilege for me to brief about this 6 days training program on machine learning for societal applications in our institution. With the financial support from All India Council for Technical Education, New Delhi, and great administrative support from our institution, it is the time now to formally inaugurate and organize this training program. On this occasion, I would like to recall the support and timely advice provided by Colonel Venkat, the director of STTP program, AICTE, New Delhi, to organize this training program. This training program aims to provide basic knowledge in the field of machine learning and explore many applications through hands-on sessions by the experts in the field. We know that machine learning is the area of computational science that focuses on analyzing and interpreting patterns and structures in data, thereby enabling learning, reasoning, and decision-making. Due to the advent of evolutionary improvements in computer science and engineering, digital electronics and communications, we are able to realize AI through machine learning, which finds its applications in all kinds of industries, including manufacturing, retail, healthcare and life sciences, financial services, etc. The field of machine learning is well explored by the research community, and several computationally efficient and robust methods have been developed, and hence it is adopted in our daily life for better living. Deep video analytics is becoming an emerging research area in the field of machine learning. Upon witnessing the rapid development in the field of machine learning and deep learning, it is much needed to have supporting manpower in order to realize the AI-enabled technology. In this context, we have made an attempt to provide the basics of machine learning and deep learning to our engineering fraternity so that they can take this as first step in their academic and research career. It is planned to discuss the applications of machine learning in the field of health science, natural language processing, e-governance, along with the basics of machine learning. The hands-on sessions were carefully designed for the benefit of participants in order to understand the state-of-the-art machine learning-based solutions, research-oriented problems, the mathematics behind artificial neural networks and deep learning, and their implementations using Python and R programming languages. On the last day of the program, Research avenues in machine learning domain, focusing on computer vision problems were planned, which would help the participants to know the complexity and challenges to be addressed in machine vision domain. I wish all participants to carry the best from this program, and I assure you that you will enjoy the sessions by listening to the renowned academicians, industrialists, and excited researchers. On the other hand, we need your cooperation to the success of this event. You are requested to be online well in time to attend the sessions and provide online feedback at the end of the day on each session for better planning. The overall feedback and the online test is scheduled on the final day. Our technical team is with you for any kind of technical support. Enjoy the days all through and take away the best. Thank you.
Thank you, Madam. I now request our Honorable Chairman, Dr. P.A. Ibrahim Haji, to address our audience. Over to you, Chairman, sir.
Bismillah ar-Rahman ar-Rahim. Is it audible?
Yes, sir.
Yes, sir.
Good morning to one and all of you, especially Mr. Brijesh Balakrishnan, Senior Vice President and Unit Head, Digital Engineering Services and Director, CSS Corp Private Limited. Mr. Abdullah Ibrahim, Executive Director, PA Education Trust, and Dr. Abdul Sharif, Principal, PA College of Engineering, and other dignitaries, officers of AICTE, faculty members, and all other participants throughout the country. I am glad that faculty members across India are striving to update their knowledge on advanced subjects of technology through conferences, workshops, and training programs. In this context, it is my pleasure to express gratitude to AICTE, which has given an opportunity to our institute to conduct 6 days short-term training program on machine learning for societal applications from 21st December 2020 to 26th December. Now, machine learning and artificial intelligence is the buzzword, and it is applied everywhere in day-to-day life. The value of machine learning technology has been recognized by companies across several industries that deal with huge volumes of data. By leveraging insights obtained from this data, companies are able to work in an efficient manner to control costs as well as get an edge over the competitors. Using machine learning technology, companies in the financial sector are able to identify key insights in financial data as well as prevent any occurrences of financial fraud. In healthcare sector, machine learning technology is used to provide real-time patient information such as overall health condition, heartbeat, blood pressure, and other vital parameters. Machine learning technology used extensively in healthcare in COVID-19 pandemic situation. In the marketing sector, it is used to analyze the purchase history of their customers and make personalized product recommendations for their next purchase. Also, machine learning helps transportation companies to predict potential problems that could arise on certain routes and accordingly advise their customers to opt for a different route. These are the few examples wherein machine learning technology is being used. Hence, Computer Science Engineering Department in association with AICTE
Chairman,
aptly chosen the topic of machine learning for societal applications. I would like to mention that PA College of Engineering is committed to provide a quality education, along with imparting life skills to the people belonging to the rural areas, and particularly encourages the rural background students for higher studies. PACE organizes many skill development programs like student workshops, hands-on training to the students, and depute the faculty members to faculty development program to update their knowledge to advanced technology like artificial intelligence, data mining, blockchain, and robotics technology, etc. To fulfill the vision to make PACE as a center of evolution for excellence in technological management and research education. PA College of Engineering, PACE Mangalore, is an institution of higher learning that offers undergraduate programs in various branches of engineering and postgraduate and doctoral programs, etc. PACE has established 2 incubation centers, namely NAIN Incubation Center in association with KTech, Government of Karnataka, and PACE MSME in association with Government of India to nurture the students' innovative of their innovative ideas and to make their ideas into reality in the form of prototype and finally to end up in startup. I am pleased to record that 10 students projects are approved by NAIN Incubation Center and sanctioned 30 lakhs rupees for this academic year, and students have started to work on approved projects along with their studies. In the recent days, we have witnessed the excessive application of machine learning based tools in all walks of our life for better living. In this context, our faculty succeeded in getting funds from AICTE to provide training on the latest scientific engineering approaches such as artificial intelligence and machine learning. I take this opportunity to thank AICTE for having provided funds to organize this training program. I congratulate Professor M. Sharmila Kumari, Head of the Department of Computer Science and Engineering, and her team for organizing this well-planned 6 days training program on the topic and invited the resource persons on as drawn from industry, academia, and the institutes of national importance. I am happy to record that this AICTE sponsored STTP has attracted 200 plus participants across the country. I am sure that all the participants will take the benefit of this STTP to enhance their knowledge and share the same with the students. It is needless to mention that many other faculty members of all the engineering branches of PACE involved in engaging in either research or generating funds from different agencies through research projects. And I wish to see our faculty members to continue this passion towards sharing their expertise by organizing workshops, conferences, training programs, hackathons, and student-oriented events. With these few words, I conclude my remarks with my best wishes to you all. And I once again thank the AICTE authorities and the Government of India for offering us this splendid platform. Thank you very much. Thank you to one and all.
Thank you, sir, for your inspiring and motivational words. We are honored by your kind and powerful words of wisdom. Thank you. I now request Dr. Sharmila Kumari to introduce our today's program chief guest, Mr. Brijesh Balakrishnan. Over to Dr. Sharmila Kumar.
Respected dignitaries and participants, we shall now move on to inauguration of this program. We plan to inaugurate this program by a dynamic technologist and business leader, motivator for young minds, Mr. Brijesh Balakrishnan, Senior Vice President and Unit Head, Digital Engineering Services, the Director, the Board of Directors, CSS Corporation, Private Limited, India. It gives me immense pleasure to introduce Mr. Brijesh Balakrishnan to the gathering. Mr. Brijesh is a technologist turned business leader with 22 years of success in strategizing, managing, and leading IT organization at the brink of change, merger, and growth. He is expertise in managing large P&L business units, global IT delivery and operations, global talent acquisition, strategic technology and application management, designing IT blueprints and roadmap, security compliance, budget management and cost control, IT governance and industry best practices. He is known as a people's leader with an impeccable track record in nurturing high-performance teams across the globe. He has vast experience in geographies of United States, Japan, Europe, Singapore, and India. He is also an industry speaker at WEF, NESCOM, government and academia events. He is the proud alumni of Columbia Business School and Stanford Business School, United States. Previously, Mr. Brijesh served as Associate Vice President and Delivery Head at Infosys. His academic credentials include B.Tech in Electronics and Communications from Government Engineering College, Kannur, MBA in Finance from Symbiosis, Pune, Executive Management in Strategy from Columbia Business School, Leadership Excellence Program from Stanford Business School, and Leadership Program on Executing Growth Strategies from Wharton Business School. We are proud to have Mr. Brijesh with us to inaugurate this event with his inaugural remarks. Sir, it is truly an honor for us. May I now request Mr. Brijesh to give his inaugural remarks and ignite the young minds through enlightened address and thought-provoking wishes. Over to you, sir.
Thank you, Dr. Shamala, and thank you, Dr. Ibrahim, and other faculty and members of the PA College of Engineering. It's my neighborhood college, so it's always dear to me. I also warm welcome to all the delegates. I can see about 84 participants, close to about 100 participants, and I'm assuming that they're from all over the country. And Madam told me that these are all professors and research students. So I have to be really scared to talk in front of you. You're all the powerhouse of knowledge, and I can remind my engineering college days where we used to bunk a lot of classes, and it's quite interesting to reverse roles and me speak something and then the professors are forced to listen. I will speak something, but then I will really appreciate if it could be interactive. If you could unmute, that's okay, madam, right? If you could unmute. No, I'm just saying that if I could make it interactive, if I would like, it will be better if participants can unmute and
yeah. Okay,
talk.
sir. Oh,
Well, so I'll
in between.
Yeah. So see, again, I think I will just try to give you a business perspective of where this is to, because I think I looked at your agenda and for the next 6 days, and it's really packed with the core of machine learning and AI and the different fields of applications and all that. So I thought as an introduction into this world, it will be given better that I give a business perspective, because I come from I'm a technologist, but then because we were there in the very early stages of IT, we only did coding for a couple of years, and then we turned into the business side of things. And I'm passionate about how technology changes business. So shall I share my screen? 1 second.
Yes, sir.
So now, I just wanted to give you an idea about. See, end of the day, the world is run by the large organizations, and they actually dictate the state of how things should happen. So this is about 100 years behind, 100 years before today, 1917 exactly. And this is how the largest companies of the world were. So you had
Excuse me,
the
sir. The
yeah.
screen is blank, sir.
Oh, is that so?
Yes, sir.
Uh,
Just a white screen.
okay, let me try one more time. Just give me a second.
Sure, sir.
Is this okay now?
Yes, sir.
Okay. Okay, so now about 100 years back, if you look at the companies that dominated the world, are actually the largest companies by market asset. If you see, almost everything about 100 years back, the biggest one were steel, because steel was the one that was powering the world about 100 years back. You had the entire industrial revolution started in, and this is early 1900, right? And you can think about this, the steel powered almost the entire industry of the world. The automobiles had started in a big way, Ford and General Motors and all of that. And the entire industry was all powered by steel. And then oil and gas was actually just starting to pick up. And then there was mining, food, telecom, chemicals, autos, and rubber and textiles. So this is how the world looked about 100 years back. And then I just wanted to compare between 100 to 100 years. So, and this is how the world looks 3 years back in 2017. And if you really see, the entire world has changed in 100 years. The largest firms, the largest of them are tech companies. The second one is financial services, and the third one is medical. Of course, the fourth one is conglomerates, because you'll have almost everything done together. Telecom, and then you look at steel is almost gone out of the play, and oil and gas is actually number two. In fact, if I would have taken a midpoint, which was about 1960s or 70s and all of that, oil would be number one, right? Because we all know about how the entire oil used to dominate the world. So it was steel and then oil, and then it is technology, right? And financial services and medical is also really picked up. If you and these are, and let me just look at this comparison, right? Between 1917 and 2017, the difference in the world. So it used to be steel, oil, mining, and it's technology, financial services, and medicine, right? The telecoms were always there. The chemicals will also be there. The retail, food, and all of that will also be there, right? But this is a big change that has happened in the world, and because and another thing that you see is it's actually millions have become billions, because of course the scale has become from million to billion. The dollar and all the currencies would have appreciated over time, and then of course the scale of business is much larger. But it's quite strange that in 100 years a million became a billion, but take that out, because you still get a comparative picture of it. Yeah. Now I'm just talking about in the 1950s, right? And this is just the US part of the world. But look at the companies in the 1950s that were massive. So General Motors, which is the largest car producer of the world, and this is steel, and this is coming out of World War. The world was just expanding. US, in fact, was doing all these 8-lane highways, bridges, and they made almost every household person to buy a car or a second car kind of stuff. And General Motors is really powering in the US and in the rest of the world. The automobile was the biggest one, right? ExxonMobil, which is the gas company, that was 2, US Steel, again Steel, Ford, General Electric, Chrysler, and again a car company, Swift and Company, Armor, it's either a steel or a oil company. And there is DuPont, which was into multiple things. Mobil is another oil company. Amoco, AT&T is that telecom company. So this is what it was in 1950s. Now look at 1970s, and this is when I said that the oil actually started to dominate in the 1970s. So ExxonMobil became the largest one. General Motors was still there, but Texaco, another oil company, Mobil is another oil company, Chevron, another oil company, Gulf Oil. You look at this, the world is dominated by either an automobile or a gas company. And then, of course, IBM was one of the only technology players in that game. But then IBM was, at this point of time, doing all with their mainframe, which is the hardware part of it, right? Now, then I looked at the world in 2000. Now, General Electric, because the General Electric, this is the Jack Welch General Electric, wherein he almost rewrote the company. And they were not just, they were actually a conglomerate. So they started as an electric company, but then they were into banking, they were into finance, they were into insurance, they were almost into medical equipment and almost everything. That was the biggest company of the world. Cisco was massive then. ExxonMobil, Pfizer, the healthcare, Microsoft, Walmart was big, Citi Group, and this is how it was in 2000. And this is how it is today, right? Now, these are extremely important. Now, just look at this. This is as of today. This is today's world view of the largest companies of the world. So, number one is Apple. Number two, Saudi Aramco just became bigger because they got listed and they became the second largest company of the world. Then you look at it: Microsoft, Amazon, Google or Alphabet, Facebook. Tencent, anyone knows Tencent? Tencent is actually a subsidiary of Alibaba on the technology front of it, which does entirely the technology part of it. And then it was Alibaba, then Tesla. So if you really look at the first 9 companies, all of them are technology powered, except one, Saudi Aramco. There's no other gas, oil, steel, or anything in the world. And this is just because they got listed, and Saudi, of course, was the largest oil part of the world, and they only got listed. But just look at where the world stands today, right? And I really want to hear from people. So what is actually powering these companies today? Do you know? This is today's world, and this is the largest companies of the world. So if you take that, and I don't know if you're aware of Hathaway, this is the financial company, again does investments in all the other companies. So you can, this is actually like a stockbroking one. So they're massive, but you can actually take them off. So because it's not into one particular industry, but it is financial services. But if you take the first 9 ones, what's the backbone of these 9 companies?
Technology.
Yeah, more specific.
Technology driven with data.
Yeah. And I don't know if we really appreciate this, right? So, and this is, I'm not just talking about technology companies here, right? I'm talking about the largest companies of the world. And of the largest companies of the world, of the 9 companies, 8 of them are companies. See, none of these are a hardware provider. So Apple does hardware, but actually the reason why they are there is not because they make phones, right? For that matter, Samsung and let's say the Oppo and the OnePlus and HTC and Huawei and all of them make far more phones than an Apple, right? And in fact, they sell it for a much lower price. But then Apple is not for the hardware, right? Apple is known because of the ecosystem of software driven by data and um, analytics, and not specifically using the word machine learning because I want to drive it there, but then that's why Apple is there, right? Microsoft, it used to be the Windows people, but no more, right? Now they are there because of the cloud, the Azure, the AI part they have brought in there. Amazon is not, you can't find Walmart at all, right? Walmart is nowhere there, even though they are the largest retailer in the world. They're not there in the market capitalization because people don't have high hopes on them in the coming future, right? Amazon is not Amazon is not there because it's a retailer. Amazon is there because it's an intelligent retailer. It actually makes decisions, or it forces people to buy only from there, right? Because Google is one of those companies that actually pioneered the whole thing about what an intelligence about data, derivations of data can be, right? Facebook also, you're not there just to meet your friends, but the power of photo tagging, the power of recommendations, the power of connecting people, the power of actually tracking you and then telling everything about you is why it is there, right? No different is Tencent, and Alibaba is actually a Amazon of China. So it does the exact same thing. And then there is Tesla. Now, and I can talk about it a bit, but Tesla is something that very recently got onto this big league of the companies in the world, right? And look at the fun part of it. Do you know how much cars do Tesla make in a year? Any wild guess? How many number of cars do Tesla make in a year? Just a wild guess. You can of course Google and tell as well, but you can unmute and talk if. Okay. So they just make 4 lakh cars in a year, right? 4 lakh. Now, and the cars are almost priced similar to a lot of other cars. Now, any idea how many cars do Toyota make? It's not double, it's not triple, it's not 4 times. It's actually 20 times. So Toyota alone makes about 1 crore cars in a year, right? Now, so Tesla makes 4 lakh, Toyota makes 1 crore. Yeah. So Tesla makes just 4% of the cars that Toyota make. Now, the second largest car producer is Volkswagen. Volkswagen does about 1 crore, right? And the market capitalization of Toyota today is about 210 billion, right? The market capitalization of Volkswagen is about 75 billion. Then comes General Motors, Hyundai, Ford, and then the list goes on, right? Now, if you add the market capitalization of all of those top 20, and Tesla again doesn't come in the top 20 car manufacturers in the world. Tesla doesn't come because they only make 4 lakh cars, whereas all the big guys are making crores and many lakhs of cars in a year, right? Now, if you add the market capitalization of all the car makers in the world, that market capitalization amount is less than what Tesla alone does it. Tesla today is at 650 billion. Yeah, by just making 4% of what Toyota makes and hardly a percentage of what anyone else makes. And that's why I said Tesla is not even in the top 20 car producers in the world. But then their market cap is more than everyone else combined together. And what powers Tesla? Actually, Tesla is, so it's not electric car alone, right? Because for that matter, Toyota, and I took the example of Toyota because Toyota has this great electric car called Prius. In fact, if anyone was in the US in the early 2000s and the 2010 to 20 part of it, They almost revolutionized the car industry there because they came up with this Prius electric car. And then so did General Motors and Ford and Volkswagen and Nissan and almost everyone. They all came out with electric cars, right? Now, Tesla is also called an electric car, but in fact, the Toyota might make more electric cars than Tesla, right? But then Toyota is nowhere there in terms of what the world is moving towards. And the pure difference is the way in which Tesla uses software. And what powers Tesla is the whole AI/ML engine of it, of learning every bit of interaction, every journey, and then communicating with the entire world. In fact, every car of Tesla is connected to each other, and there is constant updates on what each car is learning on the road while it's driving, right? And that no one has been able to crack it as much as Tesla, and that's the only reason why Tesla is there. The same is the case with why an Amazon is there. Amazon is where it is today, or an Apple is where it is today, because Apple, if you really look at it, and Apple will sell a phone for 1 lakh, and if you take a Samsung or a HTC or a OnePlus, if you take the hardware breakdown into that, they will actually sell it for 1/3 or 1/4 of that price. But they are there because of that whole ecosystem, and the ecosystem driven by data and intelligence that they are able to bring in, right? Now, no time has this happened, and these are like 5 or 6 companies, and Netflix is another one. They're not become the top 10. That's why it didn't appear in the list. But then the Netflix thing, right? The Netflix thing, end of the day, it is only about video streaming, and that is not new to anyone, right? There are movies made, and then there are TV serials made, there are documentaries made. That was there. The film industry and the documentary industry has been there for about 1,000 years, 100 years plus. But Netflix changed it because it decides on what you should watch. It tells you on what you should watch, and that's why people are there in Netflix, right? Not because they stream your favorite movie alone, but because if you're really, really hooked on, it is going to decide what you should be watching, its recommendations, its entire thing of what you like, what you dislike, and it will really tell you what to do about, right? And then the other companies that you can guess about, right? So essentially, this is one of those times when we can really find that a technology research that used to happen when I did engineering in my 90s, and then AI, ML was even the entire branch of AI itself was really an academic matter alone, right? In 20 years, it's become mainstream. It's become spread all over, and it is not that it is sold as AI, right? The beauty is that you can see AI and ML in the largest companies, in the largest product, in the largest entities that gets consumed in the world, is all there because of AI and ML, right? The the change from an academic one into a pure business one, and that is really powering, dominating, and influencing the world in such a short span, which is almost 20 years, right? The 2000s is when this whole thing came in, right? Now, according to me, there are 2 things, or in fact 3 things, that changed it in the last few years, for that matter, right? One is the whole thing is about the data part of it, right? So because when can you make intelligent decisions? You can make intelligent decisions if there is data, right? And the amount of data has to be like unlimited, right? So only in the last 5 years or so has data, because earlier what was data? Data was only structured things that were stored in a database, right? In the computer part alone, right? Unstructured data, all of that was never to be consumed or interpreted, right? It took so much of time. Otherwise you will have an RDBMS table where you put in data, and that was your only data. So what you could derive out of that data was very, very limited. Now, in the last 5 years, the amount of data is infinite. So you have collected the data, But then what you need next is about the computation power to process data, because data can sit there, but then you have to derive intelligence out of it. Then you need technologies that are available to process data, because I used to work a lot of time at Apple, and I remember in the early 2000s and all of that, when they would have those whole bad jobs running in the night. Let's say for them, one day's sale to be computed, it will take about a couple of hours. So the bad jobs used to run in the night, in the morning as well. Today it's there in a couple of seconds, or maybe even less than a second. It's available, right? So from hours to milliseconds, the way to process the data, the way to interpret the data, and then today your structured data is very less. What's really valuable is your unstructured data, the pics, the likes, the comments, the logs, everything is a data that you can process, right? So what's really changed in the last 20 years, and then primarily in the last 5 years, right, is this whole data to be interpreted, analyzed, and derive intelligence out of it, right? Then of course there is the open source community that keep powering this, and then of course after a while they get merged or aligned, or got bought over by another larger company, but then the community is so strong. And then the other big thing is also that end of the day, now it's going back to the basics of the algorithm powers the entire thing, right? The specific programming language or technology and all of that, they're all become agnostic. What's important now is what's your primary um, thought, the whole algorithm, which is the brain power of what you should be doing, is what now powers it, right? So I'll summarize it here, which is if you really look in the last 300 years, and we should be really proud of what we are able to witness. So if you really look at the first industrial revolution, which happened about 300 years back, it was all about steam and coal, right? Because and that was the most important thing. And steam and coal, the steam actually powered the ships. The ships could travel between continents, and that's how the whole the European countries almost dominated the entire world, because that's what they had in hand. Then about 150, 200 years back, electricity, US became the large force because of electricity, and then the steel. Because that powered the world, that powered the second industrial revolution, that powered large scale industries to be set up in the late 1800s and the early 1900s. The whole industrial revolution getting powered by electricity, steel, and then steel led to the auto industry and other industries kind of stuff, right? And then came the oil. So the big discovery in the 1970s, 60s kind of stuff. The whole Middle East economy starting to boom, and so do many other countries. Completely came from a very different situation. Was the oil part of it. Then, of course, there was this electronics that got in. But then we are fortunate to actually witness, and that's why I said that just look at the companies that were there 10 years back, right? They were all steel and oil companies, and just look at the companies that are today the most important ones. It is all powered by data. So it's really fortunate that we are part of a journey wherein we can witness about technology, and that too the whole AI ML is changing the world, is actually dominating the world. It'll decide the world. Now, how long, you never know, right? Because the it's not that the old steel and coal and electricity companies are no more that valuable, right? Even telecom used to dominate about 30-40 years back. Today, the telecom companies, though they are large in thing, they hardly make any profit. Today, the largest money, the aspiration and everything is around this whole data, which is led by this whole AIML part of it. So I don't think you have a better time to be part of this journey, and all of you being the torch bearers, front runners, powering the next generation of people. I think it's a fabulous, fabulous responsibility that each of you have, and it's a very, very exciting journey that we are all in, especially in the next couple of years. And if you really look at it, because it's India as a country, it's not still not got utilized fully on the data part of it, right? And for that matter, if you really look at why Reliance is big on or why almost everyone in the world, the Facebook, the Amazon, the Intel, Microsoft, almost everyone is investing in Reliance Jio, is not because they have the phone connections. It is because it is the data of the consumers, right? And that the Indian journey of data, AIML led stuff is just about to start. So might be about COVID would have changed few things, but the next 5-10 years, that's another explosion that's going to come in here. So extremely not just relevant, but actually you're all part of something that's deciding what. So it's like you have the gold mine with you and the knowledge to decide how the world and the country is going to shape up in the next few years and decades ahead of you, right? So with that, I'll stop it. Very, very happy to be part of this. In case anyone has anything to ask me, you could. I may not have answer, but at least I could hear what you have to say.
Thank you, sir, for gracing us with your knowledge and experience on the current market trends. It was really an informative session. We are deeply honored to have you as our chief guest to this function. Thank you. Due to some commitments, our Executive Director, Mr. Abdullah Ibrahim, could not make it to the program, but he has shared his video addressing our audience. Now, we would like to play our Executive Director's address to our audience.
Good morning. It gives me immense pleasure to share that AICTE has given this institute an opportunity to conduct a 6-day short-term training program on machine learning for societal applications, which is scheduled to be held from the 21st of December to the 26th of December. Our institute aims to provide quality education to the rural masses, and we have been able to achieve this within a short span of time. Under the umbrella of the PA Educational Trust, we have courses for engineering, pharmacy, physiotherapy, degree, postgraduate courses, and diploma courses. I am happy to note that AICTE has given generous grants to conduct this event, which is a one-of-a-kind, state-of-the-art knowledge enrichment program. In these days, we have seen an explosive growth in the field of machine learning and artificial intelligence, which applies in many walks of our lives. Be it a surveillance system, home automation, business management, AI and ML are there to help manage all this and more. The course coordinator, as well as the head of the Department for Computer Science Engineering, has meticulously planned this 6 days event, which include resource persons of eminence. In the course of discussion with experts, I could make out that this AI and ML program is of great significance. I am from the business management field, but I have seen the role of machine learning in many sectors, including education institution management. I also learned that there is an excellent response from all parts of the country to participate in the 6-day workshop. I am sure you will carry the best from this workshop. I assure you that you will have an excellent session covering the latest topics in the domain of machine learning, which would be useful in your career too. The resource persons are drawn from academia as well as industry. Hands-on sessions are planned, and hence you will definitely get the best from this program. With these few words, I conclude my remarks and also wish the participants pleasant days during the workshop. Thank you.
Thank you, sir, for your words of inspiration. This will inspire us to invest more efforts to attain our goal. Thank you. I now request Dr. Ramiz MK, Vice Principal, to address our participants. Over to Dr. Ramiz MK.
Thank you, Ganesh. Respected Chairman, Dr. P. Ibrahim, Executive Director, Mr. Abdullah Ibrahim, Mr. Brijesh Balakrishnan, who is my childhood classmate and who accepted the invitation to be a chief guest for this function. Thank you, Brijesh, very much. Principal, all the heads of the departments, my colleagues, all the participants from industry and academy all over India who are present here. A very warm welcome to all of you. This topic, machine learning for societal applications. Initially, when chairman talked about it, he gave a very good description about the applications of machine learning. And Brijesh Balakrishnan, he presented the topic from a business perspective, and he has made us understand that how the system has changed. And previously, the oil companies, they used to be the richest or the largest company, but now we understand the richest person, if you say Jeff Bezos, or the people, Bill Gates, Microsoft, whatever maybe he has mentioned, that how they have become the richest by using technology. And as he mentioned previously, the oil that you get beneath the earth, from the earth, that was the oil, but now you can tell that data is the oil. Data is the oil. So in a humorous mode, one person was telling that the Geo company, Reliance Geo, if you just read it from the right to left, it is OIL, oil. So that is why, as Brijesh has pointed out, many of the richest companies or the biggest companies are now investing in this Geo. And what is the reason also he has mentioned. So last few years, we have seen a lot of emerging technologies. The AI and ML has become familiar. And we also have heard about the blockchain, the data analytics, the virtual reality. And what has happened is, by this pandemic, which has forced many businesses to reduce or suspend operations, affecting their bottom line. On the other side, it has helped to accelerate the development of several emerging technologies. And this is especially true for innovations that reduce human-to-human contacts, automate processes, and increase productivity. Amid this social distancing, people have become more dependent on machines. And we know that this pandemic is basically a game with uncertainty, and we can see this pandemic as a forced opportunity to transform our relationship with uncertainty. So this actually here at this point becomes the role of machine learning or AI, where data is the major source. Artificial intelligence is supposed to contribute a major part of the global economy by 2030. So as professors or teachers from academia, I believe that this course, that is the machine learning for societal applications, we will acquire the knowledge, the know-how from this session from the academia and the industry experts. And we will also help to understand or explore the possibilities where this machine learning and or artificial intelligence can be utilized for humanity in the form of many societal applications. Because of course, in the next future, the use of this artificial intelligence, because Brijesh has explained how it has changed the complete business models in the last 20 years. And now our responsibility is that how best these technologies can be used for many societal applications to solve many societal problems, how this data can be used, how it can be processed, how it can be analyzed, and how best we can give back to the society. So for that, we teachers have got a big role in identifying the problems, the societal problems, and we should be a bridge man in between the problems and the technology, where we use our potential and also the potential of our students and provide solutions to the society. So this topic in this context is very, very relevant, that is machine learning for societal applications. And it has been meticulously planned. Dr. Sharmala Kumari and her team, they were working very hard in the last many days. Basically, this is the second part. Initially also we had a session which was very successful, maybe some 2 months or 3 months back. So I hope the same success for this program, and request all the participants to take the best out of this program and disseminate the knowledge and the expertise what we gain from this program to the stakeholders we meet or we interact. Thank you very much.
Thank you, sir, for sharing your words of support and words of confidence. Thank you. I shall now request our beloved principal, Dr. Abdul Sharif, to deliver the presidential remarks. Over to Principal Dr. Abdul Sharif.
Good morning to all. Whether I am audible?
Yes, sir.
Honorable Chairman, Dr. A. Ibrahim Haji, Chief Secretary Balakrishna, Dr. Me, STTP faculty members, and my dear participants from the academic and institute. It is a great honor to be part of the function. Sponsor short and train heart of a vision for society. I have to thank the AICTE India sponsor this STTP to college to update the advancement in the learning.
Excuse me, sir. There is a disturbance in the audio.
What the learning, and it is a subset of artificial intelligence. Our secretary, the business from the back 300 present.
Excuse me, Principal, sir. There is a
Is
disturbance in the audio.
routed earlier. Oil is dominating. Whether I'm audible now? Presently, the buzzword and applied in day-to-day life. In this COVID situation, is you contact innovative product as we want to. I understood digital learning is a subset of artificial intelligence. It is the main reduces the manpower and manpower in writing the code. In all, we are information traffic prediction, market, drawing costs and day-to-day. Chief guest explained the sectors in the last 300 years. And audible, brother.
Now,
There is disturbance, sir.
Will give the insight to the mission, societal application of the mission learning, and you will take the benefit, all the participants will take the benefit of this workshop and disseminate to the students and test for presidential letters. Thank you.
Thank you, sir, for your presidential remarks. You have been a strong backbone for us on all the departmental events. We are confident to attain the institute's and department's vision with your constant guidance and support. Thank you. Now we come to the end of the inaugural ceremony. I now request Professor Saifuddin to deliver the vote of thanks.
I hereby pronounce the vote of thanks. I would like to express my profound gratitude to today's chief guest, resource person and program inaugurator, Mr. Brijesh Balakrishnan, Senior Vice President and Unit Head, Digital Engineering Services, for sparing his valuable time and in his inspiring words. We are grateful to you, sir, for your gracious presence with your dynamic and motivating words to all of us. I also would like to thank our beloved chairman, Dr. P.A. Ibrahim Haji, PAET chairman, who is playing a vital role with constant support in all the activities of our institution under PAET. Thank you, sir. I take this opportunity to record our gratitude to our Executive Director, Mr. Abdullah Ibrahim, to address the audience for his support and guidance to all of us. And I would like to thank the people behind the success of this program, our beloved principal, vice principal, director academics, principals of sister institution, director MBA, heads of the various departments for their support to conduct this program. We have been fortunate enough to be backed by a team of very motivated and dedicated professors who know their responsibility and are result oriented. I extend my sincere gratitude to staff coordinators, technical committee members, faculty members, technical and supporting staff for their dedication and service. And I also would like to acknowledge my gratitude to our active participant and each and everyone who are involved directly or indirectly to make this event a grand success. Thank you, one and all.
Thank you, sir. Here we come to the end of the inaugural ceremony of 6-day short-term training program. I thank all the dignitaries for attending the inaugural ceremony. Thank you. We shall now take a short break. Participants kindly note that the same Zoom link will be used for all sessions, all 6 days. We shall start our technical session at sharp 11:30 a.m. Thank you one and all.
Hello, good morning. Can I get started?
Good morning, sir.
Hello.
Hello, good morning, sir. Hello.
Hello, can I get started?
Yes, sir. Yes, sir.
Yes.
Shall we start, sir? Hello. Ashok, sir. Can we start?
Yeah, good morning, everybody.
Good morning, sir. Good morning.
Okay. Just tell me whether my slides are visible.
Sir,
Yeah.
we need 2 minutes to introduce you, sir.
Okay, okay,
First-
okay.
okay.
Now, is the slides visible?
No, sir.
Okay, okay. Yeah, introduce and I'll get started.
Okay.
Sir, you can just check whether you can share the PPT.
Okay. Host disabled participant screen sharing, it says.
Okay, okay, sir. Can you share now, sir?
Okay.
Can you share?
But there is no way I can share. It says Google Drive and other things.
Sir,
Is it visible? It does.
No, sir.
Yes, share screen and it comes to all. Select a window or application. Says whiteboard, launch meeting, Mangalore webinar, mail ID. Then it says advanced. Then if I go to files, it says Dropbox, SharePoint, Google Drive. Yeah, you introduce. I'll log in once more. Let's see. You introduce. I'll log in once more.
Okay, sir.
A very good morning to one and all. So before starting, I would like to give the session details. So we have the morning session on basics of machine learning by Dr. Ashok Rao, Professor and Director, NI Mysore, till 12:45 p.m. Followed by a question and answer session from 12:45 to 1 p.m. Then we have a lunch break from 1 to 2 p.m. Then afternoon session from 2 to 4 p.m. applications of machine learning. then followed by question and answer session from 4 to 4:15 p.m. So during the session, if participants are having any queries, you can drop the questions in the chat box. It will be conveyed to the speaker at the end of the session by our coordinators. If there are several queries, the answers will be mailed to all the participants. So attendance link will be shared in every session in Zoom and YouTube chat window only, and participants are requested to submit your attendance. So with this short summary of today's schedule, we shall now commence our morning sessions. So I, Professor Muhammad Hafiz MK, Department of CSE, is honored and privileged to introduce the most eminent and distinguished speaker of day one sessions, Dr. Ashok Rao, Professor and Director NIE Mysore, to our participants. Sir has completed BE from Mysore University, ME from Indian Institute of Science, Bangalore in 1985, and PhD in Indian Institute of Technology, Bombay in 1991 respectively. He specializes in digital signal processing area and is known to be one of the leading figures in this area in India. His area of teaching and research interest includes image processing, multimedia, linear algebra, renewable energy, biometrics, appropriate technology and sustainable development management, archaeology, education and academic reforms, and ICT, etc. He has over 30 years of teaching and research experience, which includes 6 years in Indian Institute of Technology, Bombay, 7 years in Indian Institute of Science, Bangalore, 4 years in NITK, Surathkal, the rest in various places in India. He has guided PhDs both in ENC and computer science areas and has over 100 publications. He is also a solar photovoltaic specialist. Having been trained by Siemens Solar California during 1996-1997. He was the head of network project at CEDT, that is Center of Design and Technology, Indian Institute of Science, Bangalore, from 1999 to 2005. It was a project funded by Swiss Agency for Development and Cooperation and covered ENC engineering education in whole of South India, that is Karnataka, Tamil Nadu, Andhra Pradesh and Kerala. This is among the very few successful higher education projects in India. The learnings and experience from this project has been scaled up as TechWhip across India to cover broader engineering education. He is a gold medalist from Indian Institute of Science, Bengaluru during 1983 to 85. He has been awarded Texas Instruments International DSP Design and Education Award for promoting excellence in undergraduate DSP education during 1996-98. He has received citations from Philips Company for regularly crafting excellent UG students in ENC in area of signal processing and digital communication during 96-98. He is among the very few across the world to be invited to make a presentation in Pan IIT 2006 Global Meet. He is also an entrepreneur, having successfully started and managed several IT and renewable energy companies during 1998 to 2011. From 1999, he has been a consultant on design of DSP and multimedia systems to Philips, NXP Star TV, Tektronix, Honeywell, Toshiba, Sony, Infineon, Texas Instruments, Analog Devices, LG, etc. From 2007 to 2013, he has been a guest or visiting professor at Indian Institute of Management at Bengaluru and Indore, teaching PGPP, PGSCM, Executive MBA programs, and also entrepreneurship and public policy courses. He was a senior advisor for research, Government of Kerala, Department of Technical Education from 2013 to 2017, working to initiate, scale up, and diversify research in culture and competency building exercise in Government Engineering College, Wayanad. The outcome has been very impressive, with remote rural college able to do very important, diverse and valuable research in many branches of engineering discipline. He is one of the very few to have taught courses and done research in multidisciplinary areas and institutions like IIT, IISc, NIT and IIM in India. With this short introduction, I wholeheartedly welcome our today's speaker, Dr. Ashok Rao. I welcome you, sir. Without further delay, I request Dr. Ashok Rao to start the session. Over to you, sir.
Yeah, thank you very much. Let me try sharing the screen.
Yes, sir.
Is it visible?
Basics of ML, yes, sir.
Visible.
Yes, sir.
Okay. Yeah, good morning, everybody. And I will share these two files, what I use today with organizers that can be shared with all the participants. No need to copy down and things like that. Okay, so we'll look at basics of machine learning, and the afternoon session will be how to actually do in a very particular way, which is linear algebra approach. And I know the majority of the other resource persons will be doing based on neural and statistical approaches, which I fully agree is better than the way I do, because I do it from my background, and I have been doing it even before ML as a subject developed. There are a few peculiar problems which are solved very well through linear algebra techniques, and I work on that. But I strongly suggest most of the participants who may not favor
म्यूट
the
कर दी
linear.
हेलो
Yes,
हेलो
yes, hello.
Continue, sir. Yeah, it was a
Oh yeah, there's
disturbance.
too much of back channel talking. So I strongly suggest most of the participants to focus more on statistical and neural approaches. That is what going to dominate. But I will still retain my flavor, and there I know there are some peculiar problems which only this approach works well. Okay, but the 80% of what I do is common irrespective of the techniques that we use. So the basic idea is a lot more clear, and please feel free to ask questions in the end or whatever it is. Okay. So we'll see what is this machine learning and why machine learning, what are the common learning schemes, what is the basic idea of supervised and unsupervised, and consequently ideas of hybrid learning, semi-supervised. We'll also look at statistical modeling based on mixture models, boosting techniques, etc. The second part of my session in the afternoon will focus on subspace methods. We will also see that statistical pattern recognition and random sampling, random search techniques, very important, which is what makes machine learning very powerful. We'll look at one Monte Carlo methods. But for this session, the whole of machine learning will be treated as a pattern recognition problem, which truly is that way. What you do for a simple pattern recognition problem, if you scale it up in dimensions and complexity, it becomes a machine learning problem. So what machine learning does today, even if you use a GPU and do 100-layer deep net, all that, the basic idea is what a simple simple pattern recognition problem does. You cannot do that for machine learning because machine learning problems are very complex. But the idea of using designing classifiers and evaluating performance of classifier is exactly what the ML does today. Okay, even if it is any architecture. Okay, we'll look at that. So we'll understand what is this machine learning. Machine learning is basically ability to form rules automatically and subsequent use for decision. Okay, how is it done? It's done by exposing a system, and what you do in your third semester signal systems course, you have an input, a system, and an output. You do linear, time invariant, stable causal systems. You describe convolution algorithms, or in the transform domain, you do FFT and stuff like that. But here the system is more generic. It can be an algorithm, a structure like 100-layer deep net or a CNN, whatever. It could be just a lot of data, which is what the statistical methods do. And if you want to do real-time ML, you will have data coming out of diverse sensors. What people don't understand is one reason ML today is being driven and being popular is because sensors have become very cheap, ubiquitous, diverse, and numerous. Today, even if you take a high-end mobile phone, there are close to 40 different sensors available on the mobile phone, and you can actually make a sensor board which has 100 different sensors, and they are not expensive anymore. So you get hazard data of different kinds with which you can actually solve interesting problems. So that's the reason why ML has become very popular and demanding today. Okay. But why do you want to do machine learning is the following. You look at problems of society and information which are getting very complex. For example, managing Bangalore traffic is just not possible with traffic signals and policemen both. It's just not possible. In fact, it's a machine learning project given by
Excuse me,
Karnataka
sir.
government to Indian Institute of Science to see
Hello.
whether a
Sir?
better traffic management problem, solution can be emerged, can emerge using the data, real-time video data. Okay.
Hello, sir. Excuse me,
Hello.
sir. Hello.
Yes.
Sir, you have not opened the PDF file, I think, sir.
You are not seeing the slides?
I can see basics of ML and two files are there.
Is it visible now?
Click on.
Hello?
No, sir.
Sir. Now it's
Hello?
now it came, sir.
What came?
Basics of ML. The file was open.
Not visible, sir, again.
Now?
No, sir.
Now?
No, sir.
Now it came. That is
I'm not seeing it myself here on the screen.
double click, sir. Let's.
Hello.
See, I am seeing it on the screen now, my screen, but you are not seeing it, is it?
Yes,
I
sir.
think it is not shared, sir.
It is not shared, I think, sir.
It says I have to do stop sharing. It says you are sharing your screen.
Browser is visible, sir.
Hello, shall I mail the screen of PDF
Okay.
to you? Huh?
Okay, sir. Okay, sir.
I think there's some problem because I'm mailing it to madam.
Okay, sir.
Sir?
Yes.
Okay.
Or you can share it in chat box,
One
sir.
second.
I'll anyway send it. I will also try sharing it on the
Chat box.
yeah. I have sent both the files today morning and today afternoon files.
Okay, sir.
Assalamu alaikum.
Can you yourself project it?
Yes, sir. Just a minute.
Now is it visible? Hello?
Yes, sir. It is visible now.
Yes, sir. Yes, sir.
Oh, okay. We'll continue like this then.
Okay, okay, sir.
Yes, sir.
Second slide is also visible?
Yes, sir.
Oh,
Presentation
okay.
outline.
Yes,
Oh,
sir.
okay. Yeah. So what's happening with machine learning is, like I said, Bangalore traffic. Very complex tasks are attempted to be done. Not that there were no complex tasks in the past. I mean, making the first atom bomb was definitely a very complex problem, and launching the first man mission to moon.
सर आपकी सर के ऊपर हाथ है ना?
Come again? Hello? Hello? Is it visible?
Continue, sir.
Yes, sir.
Oh, okay.
Continue.
Yeah. So it is so complex. Only governments would handle in the past. Today, a lot of professionals and industries are also doing complex tasks, and the data is of exponential order, but responses are quickly and consistently required. Typically, in pharmaceutical industry, using genetic data, genome sequences. Genome sequence data is a database which is as big as your lab, okay, volume wise, as big as your computer lab, filled with memory which is having the global genome database, okay. Now, what is pattern recognition kind of from? So what this pattern recognition approach or machine learning approach to problem solving is to extract structure, pattern, and rules within codes. The rules need not be as simple as your Boolean functions, but if it can be extracted, would be very valuable and useful in finding appropriate responses for present data and future. A lot of your Aadhaar card, data mining, text-to-speech conversion, and even the problem where I speak now and it can be converted to text in real time. That's again a machine learning problem. But more interesting is problems of medical imaging and more recently COVID. So what I know is What I know about COVID issue in machine learning is that what we are able to know about machine learning thing is that almost all the companies which have produced trial vaccines now have done ML analysis of COVID data. And one of our students from IAC is actually in Bangalore working in a company where first 1 month of all scan and the pathology data of Italy, where that was the biggest COVID strike, that data came to Bangalore for analysis, and they picked patterns of infection, patterns of cure, and patterns relating to robustness, all that, and they have analyzed that and got it back to pharmaceutical companies to assist them in zeroing down or narrowing down to a potential COVID vaccine. So that's one reason why the COVID vaccine, at least a trial vaccine, has been produced in 10 months, where in history of time, one of the earliest vaccine has been in 2 or 2.5 years. And you look at the AIDS virus, even after 20 years of research, there is no cure for it yet. There is no vaccine for it yet. There are only certain preventive and palliative cure. There is no firm cure. And so you can see how complex the problems are. Okay. So why this machine learning has suddenly emerged as a good alternative to conventional way of problem solving has been, first thing, a lot of pattern recognition is quite mature, and we have been doing pattern recognition now for 40 years. Okay. Image processing, little over 50 years. Statistics and advanced ideas of hypothesis testing, little over 70 to 80 years. Algorithms for clustering of data, the primitive algorithms have been about 40 years, but there are more efficient clustering algorithms now. Learning theories and methods, supervised, unsupervised, hybrid, boosting strategies. Learning theories have been about 40 years, 50 years, and boosting strategies have been 20 years. Design of classifiers, neural and non-neural classifiers, about 70 years. A few tricks like kernel methods, 20 years. So there is nothing new about machine learning. It's just that under one topic or one subject, all these have come together. So this is another thing we need to learn. Now and in future, convergence of many ideas, many topics will be there. And real life is also like that. Okay. Only we have done very stupid curriculum, and one of the most stupid curriculum on earth is actually VTU curriculum, because they want to put all subjects separate, make everybody learn different things with no connection. Therefore, when they pass out, they have no connection to any problem that they can solve. The best student will be familiar with C coding, and the colleges are very happy, parents are happy, the students are happy. Only people who are concerned that nice things are not happening, they are the only ones who are not happy. Okay, and I belong to that set. Okay, my only question is, why are so many students in so many colleges at undergraduate level wasting 4 years of their precious time, energy, and talent learning all unnecessary and unwanted things? Okay. So what is the supervised learning? Supervised learning is what under supervision you learn, which is exactly what we do in class, or we attempt to do. How is it done? We are given many examples for which the answer is correct. We are also told what are the wrong answers, or something we do wrong. We say, okay, this graph is not all right. This coefficient is not correct. It doesn't converge to the answer that we are looking for. So explicitly providing questions for which answers are correct, similarly giving questions for which answers are no, or giving questions for this for which answer is yes, and also tell them when the answer is wrong. So very clearly give problems for which answers of yes and no are very well defined. That is what the teacher does. Teacher does in the class, he or she works a worked example from the book, explains how the working is, then gives a problem perhaps for which only the answer is there in the book, but the working steps are not there, and then gives a problem in the first test for which only he or she knows the answer, and he or she checks whether you have learned how to solve that, and if you get an answer correctly with what the answer is already known, then you get full marks. You get part of the marks if the steps are correct and you make mistake. Same tamasha is repeated in the exam. Okay. So what it does is the following. You are not giving data about this square, this ellipse, this torus, this star, all that. What you are telling is, if the object, the color of the object is blue, the shape of the object is torus, and if the size of the object is big, the answer is yes or one, Boolean. One, yes, desirable, not desirable, permit, not permit, whatever you want. Okay. Similarly, color is blue, shape is square, size is small, you declare one. Color is blue, shape is star, size is small, yes. But if the color is red, shape is arrow, and the size is small, you declare output no. So basically, what this problem is all about learning to approximate a function given three parameters, x1, x2, x3. These are called the features. So first shift from regular computer science to machine learning is we don't deal with data directly. Lot of data has to be analyzed to get answers, but we don't deal with the numbers alone. That is intimidating, impossible to do, because today data is of terabyte size. But even if the data is very large, features about the data are very few, and there are some dominant features by which we solve the problem. Take the example of recognizing your friend after so much of COVID break. How do you recognize your friend? He or she will not come and say, hey, I'm your friend, I'm so and so. Do you remember me 10 months back? We were in the same class. Nothing like that. You see the face, and based on that, you immediately conclude who the identity is. Little of the face may be changed. If it is male, he may have grown a beard or whatever it is, hairstyle may have changed. They may have lost weight, or they may have actually gained weight in COVID times. Well, oh, you become, plumpy, you put on weight, what has happened, etc., etc. So humans do that. Humans solve problems as a pattern recognition problem. We don't do data processing. We are very poor at data processing. If I give you a 5x5 matrix and ask you to invert, you will take at least 2.5 days and finally do it wrong. All of you will do it wrong because it is intimidating to even invert a 5x5 matrix. But if we go to some place and meet strangers, in 2 minutes we will recognize or understand them and start talking in a neutral language, whatever it is, even broken language, because both of us don't know each other's language, we know something in between. Very quick. So humans are exceedingly good in pattern recognition. Computers are very bad in pattern recognition. Computers are very good in data processing. Humans are very bad in data processing. So what we do, we want computers to help us with our needs, and our needs are pattern recognition needs. So all the effort is to make computers solve pattern recognition tasks, and that you call it machine learning. Okay. So what it does, you give lot of problems for which answers are known. This is called training data. Okay. So what is a training set? A training set is lot of data for which features for the data are known, and the answers for that are also known. So from a training set of x1, x2, x3, these are three variables, and these variables are not data, they are features about the data and a truth function, classification. Okay. It need not be three variables. If you look at your face on the mobile phone, which is recognized, each is recognized as a 8x8 block, which is 64. So 64 features are more than enough to solve the face recognition problem up to 99.98% accuracy. Okay. So supervised learning means looking at problems for which data and the correct answers for the data are known. Okay. That's why you have textbooks where problems are solved in detail. Then there are like Sham series. There are problems for which answers are given. Then there is another set of exercise for which problems are given, no answers are there. So it is a good way to train. That's why Sham series is a very popular book where teachers don't teach or are not there to teach, and students have to learn on their own. This is supervised learning, how it works. So learner is a system. That system receives input for which data along with the correct answers are fed. What does learning mean? Learning means it internally hypothesizes the function. What function? This function. Learn to approximate this function from input feature space to output decision or a classification space. It learns. How do you know it has learned well? Like our VTV exam. How do you know the college has taught students well? There is a university exam, common question paper for all the 180 odd colleges. Students are asked to answer them. So, what kind of answer? Questions and data is given. Answers to that is not given. You are taught and you learn. You answer the questions and write your answers. You say, okay, for the first question, answer is yes. Second question, answer is no. These are your prediction answers. This prediction is compared with a known answer for which it was not supplied to you. So the examiner, the question paper setter would have given what are the correct answers. Evaluation people will compare what you have answered with what the template says, and based on that, give marks. So this is how learning is. What kind of testing is done? Testing is done on very similar data for which you were trained. For example, you have, so there is a standard excuse. Whenever students are not able to answer a question, first comment you write saying out of syllabus. Okay. Very easy to declare out of syllabus. Now the question is out of whose syllabus? Okay. Very standard, out of syllabus. What they are indirectly telling is, I was tested by data and classes for which I was not trained. This frequently happens in medical field. People are trained, let's say, to do arm surgery on the arm, and the examiner comes and asks to do the surgery on the leg and shoulder. Okay, there is small difference, no doubt about that. So the students will say, oh, I've only been trained on hand and I know how to cut fingers, but I don't know how to cut the toe. Okay, whatever. Supervised learning is this. When is the supervised learning very successful? Supervised learning is very successful when all the testing data, hopefully which is similar to the training data, have output classes for which you were already trained. This is the IIT JEE exam. What is IIT JEE exam? IIT JEE exam means you have solved problems, patterns of which come in the final JEE question paper. Numbers here and little there may change, but the pattern and the class for which the answers are will not change. That is why people go to JEE coaching classes. What is coaching class? Coaching class is training you for all the possible types of questions and answers. That is all. It has nothing to do with intelligence. It has nothing to do with thinking. Okay. That is why all these people who are successful in CET, JEE, all that, they do very poorly in real life. Because real life problems are not pre-trained. People who are able to think for themselves eventually solve real life problems better than people who have been coached and trained. Supervised learning is useful for automation, but rarely useful for new things. For new things, we have to do something else. Now, what is the problem with supervised learning? The problem with supervised learning is this. I had trained the machine for this as yes, also this for no, but your input is blue color arrow or a yellow color torus. What should the answer be of the system? It will see. It will not say, I don't know. It will always give another problem with machine learning. There is always an answer at the output. It is like our MATLAB plots. You, as long as the syntax is correct, some plot is available and the plot can be doubtful, but if the plot is in color, even the teacher will not worry. Oh, it looks very nice. It's a perfectly wrong answer, but it looks beautiful in the printout. Everybody is happy and gets full marks for a perfectly wrong answer. This is the problem. Here, it will give an answer. It will check whether of all the features between color and shape, whether the shape feature dominates, in which case for blue arrow, it will say no. And if the color dominates, it will say yes. Same with this. I give a yellow torus. If it has been trained with more and more of yellow colored shapes and objects, it will declare this as yes. Otherwise, it will declare this as no. This is the problem. No generalization, very specific. This is a bakra, yes, this is a bakra. This is a horse, this is a horse. If you give a mule, it will not know it is a mule. It will classify mule as a horse because there is a lot of similarity between horse and mule. This is a problem. But if you are going to deal repeatedly with problems that happens, let's say in human life, like traffics and other things or payments and all that, you repeatedly encounter the same thing. Supervised learning works very well. Okay. So what you need is, you don't need exhaustive training. What you need is rich training. That's why training data is exceedingly important. Can I teach the course, first module of the course, let's say with 4 or 5 problems, which cover all the concepts? That is more important than solving 200 problems on Ohm's law, which is what is done in colleges. Exhaustive training, not rich training. So it is like trying to recognize characters A to Z in shape. How many training data do I need? I need minimum 26 data. 1 for A, 1 for B, all the way 1 for Z. Suppose I give 400 samples of A and no samples of B to Z. It is exceedingly exhaustive training, but very poor quality training. Another thing to remember in machine learning, you are going to solve qualitatively, not quantitatively. Therefore, a good machine learning examination answer book will have at the most 2 pages of writing. Today in VTU, we have more we write, there is hope of passing. Suppose you write 35 pages, any garbage, the examiner is forced to give 1 mark for each page and 35 over. This is how Indian university system works. Okay, too quantitative, but ML is not like that. It is a high focus on qualitative answers. How are all these hypothesis spaces? That is, how do you model your decision or answer for which data is to be fed, you do that various ways. It can be a decision tree, it can be a neural network, you can use a neighbor, k nearest neighbor, you can do Bayes classifier if you have good data which and relationship between each data point, or it can be support vector machine, it can be a boosting technique, and dash dash dash. This is another problem. People know C coding. If I ask people what else you know, they'll say C++. Not one student says they know how to solve a problem. They have mistaken engineering for syntax. And colleges are very happy because making students solve problems is demanding on the teachers. Making them remember the syntax is very easy. Therefore, our engineering colleges today is slightly better than kindergarten. That is the level at which the teaching and learning goes. Okay. You need to know at least 12 ways answers can be structured. Because in machine learning, every problem has multiple correct answers. You need to pick the best based on context. So that's an optimization issue. Getting multiple answers means there are 10 different ways to solve the problem, all of which give you an acceptable answer, and you need to pick the best among the acceptable answers. So we need to know how to solve problems in many ways, which means we need to know how to think about a problem in many ways. This is never taught. For example, eventually the problem boils down to a very simple answer. It says, I have a lot of data. Can I find a means to separate all the data at least to say 2 groups? In this case, all the blue circles, and in this case, the yellow squares. So data is given like this. I must find this line. This is called the classifier or a separator. How do I learn the separator? This equation is y equal to m1x plus c1. I need to learn 2 parameters, m1 and c1, given the data, which is what statistics people were doing in line of least regression. Okay. So I want to fit to 2 classes. Suppose the problem has 20 classes. First do for 2. Then from 2 separate further. That becomes like a binary tree. Yes, decision tree is one way to separate. Okay. So first learn how to separate into 2 distinct groups. Then from 2 you can make 4. There is no problem, because one thing good with computer, if you learn how to solve it once, you just have to repeat it n times. Okay. Now the other problem is this. There is one more answer. This was one answer which broke it into 2 groups. This is also another answer. If you work harder, there will be one more answer. One more answer. There are, in fact, at least, even by looking at it, at least 12 correct answers. Of all the 12 correct answers, which is the best answer of the lot? That is the problem of this. The best answer among all is that straight line which gives you maximum separation between the 2 classes. This is what is called the support vector machine. So again, with machine learning, don't get carried away, confused, intimidated by all the terminology. Don't do that. All the terminology finally are very simple things. Many times terminologies are put to have a generalized idea, and many other times terminologies are put so that readers are confused and threatened, so that there are no competitors for them in future. It is like teachers who scold the student for asking a doubt instead of clarifying, and for the rest of the career of the teacher, nobody will ask a doubt. And the teacher will definitely not improve because he or she never clarified a doubt for others. So this is just the opposite of it. Okay. Now, all data need not be separable through straight lines, because we are looking at simple solutions and we want the simplest structure to separate two groups is a straight line. Now, all data need not be this thing, and in fact, you can have very bad data shapes by which this is something like a 10th order curve, which separates this. What is more interesting is, can we do this? Take this case where you have the following. You have all dashes and you have all pluses here. Just forget the line for the moment. So you have data like that. I want to find a boundary like this, like a squashed up ellipsoid. Okay. That would do. Maybe it's a 10th order curve. Even better, I can find one straight line, which is M1, C1. I can find another straight line M2, C2. I can find another straight line M3, C3. So M1, M2, M3, C1, C2, C3, 6 parameters if I learn or coefficient. You see the intersection of these straight lines. Everything inside the intersection of these lines is one class. All that outside is another class. That's all. So it finally solves a two-class problem using simple classifiers. This sometimes is also three-layer neural network, because every single layer of a neural network is a straight line y equal to mx plus c or m1 x1 kind of thing. This principle of solving a complicated decision boundary like this, one boundary like this, by intersection of three simple boundaries, comes from a principle called Occam's razor, which this person, William of Ockham, in 1320 AD, told the following. Of course, he mentioned it in Latin, but in equivalent in English is, entities should not be multiplied unnecessarily. What it means is, do not complicate. Finally, whatever is good is simple. It has a simple explanation. It will have a simple model. It will have a simple structure for implementation. And suppose you are encountering very complex facts, treat complex facts as a combination of simple facts, implement it in simple terms, it will work. This is also the same as a boosting strategy. What is boosting? What does the simple classifier one straight line do? One straight line is a weak learner. What does a weak learner mean? It's not able to solve the problem, but it says the following. Everything to the right of this line is in one class, all dash, correct. What does this line say? This line says everything below this line is one class. What does this line say? This line says everything to the left of it is one class. Suppose all these three straight lines agree, that is, they intersect here, here, here. The region defined by the pairwise intersection of these lines have the following answers. It says outside this, outside in the sense of left, outside in the sense of lower, is a different line. Together, they have solved the problem. This is teamwork. This is real teamwork, where each person solves correctly one portion of the problem without trespassing into other and all. That doesn't happen in fact, teamwork is the most difficult work to achieve. Okay? So it's a simple classifiers which are weak learners can have their performance boosted by taking weighted combination. Boosting also maximizes the margin like your support vector. Okay. So given this, we have achieved significantly difficult task by using simple combinations. Rest of your life, please follow this both in life and in machine learning and other things. After all, we are not sending man to the moon. We will never encounter such a complex problem. We make a simple problem complex because we have no training to solve problems. We are worried about ourselves, and in the process, we also make a mess of things around us. And a good example is how many of the colleges and departments run. Very simple. Students pay fees.
You are all having a job, which is very difficult to find job these days. The least you could do is teach well, enjoy it, convey things well to students, let them enjoy the learning. What more you want? You are smiling, they are smiling. That's all the purpose is. Instead of that, we have all other parameters and do mess of it. So, lot of success for supervised learning. Entire face detection in your mobile phones is supervised learning. Steering a autonomous car, that is driverless car across US is there. All your credit card frauds immediately detected is again trained, and lot of medical diagnosis today. One of the most rewarding career in the sense of commercialization. A lot of money is there in this, where a lot of data from all over the world actually comes, and very difficult to get a radiologist or an oncologist to sit on such data and label it. So they have labeled the data of the past that is used for training, and all the new data that comes is automatically labeled. All the nice clear cases, fourth stage cancer, very clear. First stage cancer, very clear. Second, third, and fourth, particularly third and fourth stage, very difficult to distinguish between third and fourth. So all these cases are pulled out for a human intervention. But what is very clear, which is approximately 90% of the cancer cases. 90% of the cancer cases fall into first grade cancer, fourth grade cancer. Fourth grade cancer, don't treat, call the ambulance and make a announcement in the obituary column. First stage cancer, very clear, mild treatment, no issues. So this is how supervised learning is very, very commonly used. Okay. So what does a supervised learning eventually do? It learns a mapping from input to output. That is, input is set of training sets with features, output is classes. Today you can say input is feature space, output is decision. Open the door, close the door, release the money, don't release the money. What? So you 1 or 0, yes or no, truth or false. So 2 class. Okay. Those are decisions. So basically, machine learning is function optimization from input, not from data. Cousin of the data space is the feature space. And output is not the output space, but the cousin of the output space, which is a decision or a action space. Okay. And it can be drawn, this function can be drawn from different ways. We saw so many ways the hypothesis can be built, like decision tree, linear separators, linear in high dimension, mixture of linear separators, all the a lot of algorithms, plenty of algorithms today, which offer variety of give and take, and many good books. In fact, if you want to get into supervised learning, you must follow these 2 books. The Elements of Statistical Learning. There was earlier edition, but this latest edition. And this pattern classification book by Dutta and Hart, which is what we studied in 1980s. But third author came, and this 2001 book is good enough. Okay. So this is so much about supervised. Now the problem is not that, the problem is more severe. Now what happens if there are no labels? I don't know the answer to the data. What do you do? What do you do there? We'll go back and see what we did so that we'll learn what to do. Up to now, we did supervised learning. What is what? They were samples, data samples, and there were labels for each sample, to which class it belongs and stuff like that. This was also called learning with the teachers. Its correct answer is provided along with the data. But now, unsupervised, we are simply given samples. This is also called learning without a teacher. Its correct answer is not provided. You cannot split the data into training and testing data, which you did here, because I don't even know the labels for this. What do I do? How do I handle such data? And how common is such data? This data is amazingly common. In real life, lot of it is unsupervised, which means you encounter something which you had not experienced before or you are not trained to handle it. How do you do? What do you do? What do you do to make it right? Because the penalty for doing it wrong is terrible. This is also very frequently seen in the legal system, where even experienced lawyers encounter cases which they have never handled such type in the past. And they have actually blundered. I know they have blundered. So, encountering not unseen data, but new data for which you don't know the labels or you don't know what is correct to be done about that is equally common. That is unsupervised. What do you do? So what unsupervised done is like this. Just take this simple example. I have a set of fish and I don't know what they belong to or where they are, what group, etc. So I can, if I know a lot, it's easy. But if I don't know, what I know can figure out is I can observe and say, okay, let me group all the smaller fishes into one group, all the bigger size fish into another group. These are called clustering. Many times natural clustering happens. For example, in your college, when there is some function and you all assemble in the auditorium or something like that, naturally you will see that the first person who goes and sits, if it is a boy or girl or a lady or gentleman, if they go and sit on the right side, then immediately the next person of the same gender will go and sit on the right side. And soon by the time the seminar or the auditorium starts working, you will see natural clusters, all the ladies on the right and all the gents on the left. If by chance, if that first person who was a gent went and sat on the right, people will build up a queue and a cluster around him. And this happens very frequently in bus stop shelters, in etc. You'll see in a bus stop shelter, one lady is sitting on a bench. Some other lady comes, she has to go somewhere else, she has to wait, but she will see which bench is empty. If there are no empty benches, she will go and sit in a bench where there are already ladies. That's natural clustering. Very natural clustering. We do that. Natural clustering is another human evolution, just like supervised learning. Okay. So, unsupervised learning is harder because we don't know the results are meaningful because no answer labels are available. Later, we let the expert look at the results, which is an external evaluation, or we define an objective function on clustering, which is an internal evaluation, which is what most of the algorithms do. We nevertheless need it because labeling large data set is impossible. And we have no idea how many classes there are in data. For example, in data mining, we may want to use clustering to gain some insight into the structure of the data before designing a classifier. So I just want to group similar looking data and see what is common with all of them. Okay. For example, when you go abroad, if you mix up a North Indian and a South Indian, but for a European, all Indians are the same. Within India, North India and South India is different, but within Karnataka, Kannada and non-Kannada is different, and in Mangalore and other regions, it is even more complex cluster. Tulu, Konkani, Malayalam, English, Hindi, Kannada, everything is there. So, how do you group? For example, a South Indian may not understand Hindi. A European will not understand Hindi. But if a North Indian speaks Hindi in front of a European, the South Indian there may not understand the language, but he knows he is related to that language because they share the same geography. This is what it is. Okay. So, what is common with a North Indian and South Indian is perhaps something like, or you speak in Kannada, the North Indian will not know it is what the Kannada language is, but he knows it is not a European language. Okay. So these are the kind of clustering that happens. We find it when we go to a very cosmopolitan atmosphere which many of you may not have experienced. You go to large gathering like IIT or IAC hostel, and in the mess you will see that automatically people converge. There is a Kannada table, there is a Telugu table, there is a Malayalam table, etc., etc. Unordered. Every day it's not the same table, but the first person who goes is the seed point. He goes and sits. His friend from the same region comes, because there's one opportunity for them to talk in their language and catch up with the state gossip or their favorite hero, whatever. Okay, so natural clusters happen. Okay, this is it. You see here. I have 3 plus 4, 7, 7 plus 3, 10, 10 plus 3, 13 data points. And how many clusters? For example, I can have one cluster with all the 13 data points, which may not give me good information about the group. Or I can have another extreme, 13 different clusters, all isolated. One stage confusion, another side no clarity. Whereas here, data points which are close to each other. Suppose I put a center point here and a radius R1. I put all the data with a center C1 and a radius R1 within that here. Similarly, center C2, radius R2, center C3, radius R3. I have to fix R1, R2, R3. This is the idea of clustering algorithms. Of course, I also have to seed various centers. You can do in a deterministic manner, which is very inefficient. Today, random clustering algorithms work very well. Randomly, you distribute seed points, C1, C2, Cn, and randomly probabilistic distribution, put R1, R2, R3, build the clusters and iterate. And in few hundreds of iterations, you will see an exceedingly good minimum error solution. Okay. So, but what's the idea of clustering? What is a good cluster? That metric has to be identified. What it does is the following. If the internal, that is within the cluster, distance between points, if they are small, and the external, that is distance between center of this cluster and center of this cluster, if that is large, then clustering algorithm does a very good job. This is called minimax. That is, you are minimizing the internal distance, maximizing the external distance. So frequently you will see this minimax operation coming, and that's when one good way to cluster. Okay. So a lot of nice problems they have solved. This is it. You need similarity measure. That is, you say x1 and xi and xk are similar. If in what sense? If the distance between the two is small, x1 and xk are similar. If the distance between the two are large, they are dissimilar. There is some mistake here. Okay. So if I have large distance between two data points, you say it is small similarity. If you have a large similarity between two data points, then the distance between these two data points is small. Then there's a criteria function to evaluate the clustering. For example, this data problem has one answer, good clustering. This is also an answer, like ML. For every problem, you'll get an answer. This is a bad clustering, but it's a clustering. A lot of good clustering algorithms today, and there are doubts how many clusters. Is 3 clusters a good solution or 2 clusters a good solution? That you have to decide, working out the distance between intra-cluster and inter-cluster. Okay. Now, what they probably do is they don't start with 1. They fix the number of clusters and iterate around that. Okay, increase the number of clusters or decrease the number of clusters. Find the metric or evaluation function or the objective function. Find the minimum value and go ahead. Okay. So, other problems with clustering is this. You see here, I have image of a face. I have this image of a face. The distance between the two is 0 because this image, if I rotate it anti-clockwise by 90 degrees, it looks. Therefore, you must workout cluster should be invariant under transformations natural to the problem. For example, invariance or rotation. But for character recognition, you must not do that. For example, 9, when I do this 180-degree rotation in the clockwise direction, it looks like 6. 9 is not the same as 6. Therefore, the distance between 9 and 6, you should keep it very large. So these are all the problems of clustering algorithms, okay? And there are many distance metrics. Euclidean distance, which you are familiar, the Manhattan distance, the absolute sum, and the Chebyshev distance, which is the maximum of it. So this is really, for example, here, this is one distance, this is another distance. The maximum of the two is this, so you take this. So normally L1, L2, L infinity norms are used, which is standard for solving such problems. Then there's idea of what I told you about K-means clustering, which simply says the following. I have a lot of data and I put seed points, number of clusters K. I guess the initial cluster center. So this is center mu1, mu2. And then I assign points to this cluster depending on, let's say, the radius and some norm. This also works. You reiterate hundreds of iterations, thousands of iterations, it will converge. What are the options for unsupervised learning? You can do an expectation maximum algorithm for mixtures of Gaussian, a soft version of the K-means, use base criteria to select K, do Monte Carlo simulation. There are some exceedingly good problems that were solved because they discovered new type of stars from spectral data, because astronomical data by nature is astronomical in magnitude, terabytes, okay? It also discovered new class of proteins and introns from DNA and protein sequence database, which were never identified by humans before, because it was too large, petabytes of data. Within that, it's like searching a needle in a haystack, and clustering algorithms do that, okay? So, a lot of interesting ideas, clustering, hierarchical clustering. You can do dimensionality reduction, which will come to in the afternoon. You can do nonlinear dimensionality reduction, build up learning rules for instance. So from clustering, you can build up learning rules. From that, you can attempt a supervised classification. That's how the hybrid classification. 1 or 2 passes of the clustering. From the clustering, from the group, extract features, use the features to train a supervised learner. And so a problem for which the answers were not known very well slowly emerges and comes with very good answers. This is how the COVID data thing was done, okay? So you have some prior knowledge about not COVID virus, but cousins of the COVID virus. COVID-19 is one of the families of COVID virus. There were other COVID viruses earlier. So they have a graph model with about 1,000 nodes. 1,000 or even more than 1,000, 10,000 nodes, which you cannot enumerate by hand. Structure that and make a supervised learner learn this. It builds a hypothesis, try out experiments, expose it to real world. If it doesn't give very good result, use the wrong results and retrain it. Maybe some more nodes get added or some more nodes get merged. Some more nodes may actually get deleted. Slowly, this is how computer-assisted pathway for refining the answers is. Today, it's done in all the labs. Okay. And there's another technique called the nearest neighborhood technique. Very interesting. What it simply says is, remember all the data. When someone asks a question, find the nearest old data point, return the answer associated with it. For example, somebody comes in front of you wearing a turban. What do? You don't know who he is, what he is. You must give a label to that. What do? You remember. You remember in movies, you remember descriptions that anybody with a turban is a Sardarji. So you will say this fellow is a Sardar. That's all. You don't know who that fellow is, but you remember old data associated with what you are observing, whatever feature. For all you know, he may be your close friend who has put a turban for some fancy dress competition. You are wrong, but you have given an answer. And that answer fits because the old data fitted this. This is your idea of nearest neighbor. And it works very well. Interesting. You see here. It handles mixed variables. It handles missing data. It is efficient for large data set. Handles even irrelevant attributes. Easy to understand. Predictive. So nearest neighbor, k nearest neighbor, all these are exceedingly interesting algorithms for unsupervised learning. Okay. You see here, this is how it did. Today in huge genetic sequences are mapped backwards to find out where we originated from. Okay. You see here, very clear, fish and birds, they all came from the same source. It's very well known now that fish and birds had the common ancestor, which you see now. In fact, amphibians like frog and crocodiles, they breathe in air, live in water, live on land. Frog puts eggs in water, but crocodiles put eggs on land. So many things. Okay. So this is how when it uses expectation maximum with a maximum spanning tree in the inner loop for algorithm implementation. This machine learning, why it is really unstoppable now. Lot of fast computers, including GPU processors, not Intel processors. Your 8085, 386, Pentium, they are no good anymore for anything useful in future. I think if Intel doesn't change its attitude and build up powerful GPU kind of architecture, Intel will have to close down. And it will be good if it closes down. Okay. A lot of data because lot of sensors, internet traffic, etc. The web, then the online machine translation that we experience, so many things. There are new ideas, lot of new ideas which have come. All these are being used. So suddenly ML has emerged as a bhuta, and suddenly, which was nowhere, it now scares us with the dominant model. So what ML is actually a pattern recognition problem. Architecture of the classifier may change. It may be a CNN, it may be a recurrent neural net, it may be a linear regression model, it can be a non-linear regression model, it can be a subspace, whatever, but it still is a pattern recognition problem. It starts with broadly labeled data, supervised, and sometimes unlabeled data as the basic. The classifier models, architecture, the learning rules, the metrics you choose, and the training scheme may all change, but basically it's a pattern recognition problem. Okay. So we will briefly build this little of what is this pattern recognition and go on further and do that. How much time do I have now? How much time do we have now?
Sir, 10 more minutes.
We will do the session and take the questions later in the afternoon. How is it?
Anyways, okay, sir. So till 1 we can have the session. Afternoon we can take the questions.
Yeah. Afternoon we can take the questions after the or just
after your session. After your session. 4 o'clock almost.
So we'll see what is this pattern recognition one. So this is idea of pattern recognition. What does pattern recognition mean? It recognizes patterns in data. More formally, it assigns an object or an event to one of the several pre-specified categories called classes. For example, I give this data and I ask whether what is this data? All of you can see this data. You will see this is a face. But if I give this data as numbers, gray code scale value, most of the time the machine will recognize this as a phone because historically phones were looking like this with one receiver and transmitter together. That is, you couldn't do simultaneous reception and transmission. You could talk and the other fellow hears, or the other fellow talks, you hear. After that, in fact, if you go to some museum, you'll see a phone very similar to this. This face is more similar to a phone than a face, but humans will declare this a face. Unless you train the algorithm very well, the machine is likely to put it either as a phone or as a teacup. There have been many teacups with these kind of features. So pattern recognition is not easy. It is relatively easy for humans, but very challenging and difficult for machines, which is what we are trying to do now. Okay. You see here, I have data, which is called objects. Okay. Because we look at feature space, not just the data. So I have objects, which are pictures. If I design a pattern recognition system, it will classify the pattern recognition problem as two classes, male or female. Let's not worry about the neutral gender, all that kind of thing, which is a sociology problem rather than a biology problem. Okay. So it will classify this into male and female. It classifies by using the data being trained. Okay, this is a male, this is a female. You keep training and put more and more images, it will classify. One correct answer. You look at the same data, another correct answer. I have lot of same data. I train it in a different way. I train this as a photo and I train this as a sketch, not a photo. Photo, not a photo. This is also correct answer. So of the two correct answers, which is more correct? I don't know. You must tell me what context. Are you looking at gender classification or are you looking at photo and not photo? So this is another thing with machine learning. Multiple correct answers. Unless you know the domain and the context in which you are trying to solve, you are quite likely picking the wrong correct answer. Therefore, another thing with machine learning, if you want to do machine learning, you must learn one or two domains. You just cannot say, I know C coding. You must learn a domain because the domain knowledge builds the context in which you validate the answer for its effectiveness and correctness. Not whatever just comes out of the output of a, let's say, even a GPU processor. You use a 100-layer neural network, deep learning net, put the data, it will give you an exceedingly correct answer. But you don't know whether that answer is useful because in the what domain are you using? What is the context in which that is correct? Because multiple correct answers are definitely feasible. Suppose it's a character recognition problem. You have written handwritten words here, hello world. A perfect pattern recognition system will classify it as hello world. In these cases, all the characters A to Z, 26 classes are the grouping. What about medical diagnosis? I have given lot of pathology or scan report or whatever. It will classify it into cancerous cells, non-cancerous cells. How does it characterize as non-cancerous cells? Non-cancerous cells are more or less regular in shape. Cancerous cells are irregular in shape, different colors sometimes, all this. So I need to know, given the cells in the body or in the blood or in the tissue, whatever, I must know what are the features of a regular healthy cell, what are the features of a cancerous cell, then train this. After that, I will count. I have 3 plus 3, 6, 6 cells. Out of 6 cells, 3 are cancerous. 50% cancerous cells means most likely it is a 4th degree cancer. That is how I work. Automatic, okay? What about speech understanding? I give a waveform. It will convert it into text. It will say recognition. It will not say RECOGNITION, not our spelling. It will put it closest to the acoustic. So recognition. You may write it as recognition in English later, but this is how it really sounds to our ear. So in this case, all the different classes are various phonemes which people with linguistic background would know. That's why if you want to do speech understanding or speech recognition problem, you cannot just do natural language processing without knowing the linguistics, without knowing the phonemes, without knowing the acoustic versions of that. Lot of domain knowledge is needed. So we will stop here. We will take this pattern recognition problem and solve an interesting case of catching fish and sorting it into two classes, which today a large number of fishing boats automatically have this on them. So this is not it's a toy application problem, but it is no more a toy because there are at least 1 million fishing boats even in Mangalore which have this facility now. Okay, yeah, we will come back at 2 o'clock. If there are any 1 or 2 quick questions, I can handle for the next 5 minutes.
Dear participants, any questions? If you have, just you can unmute and ask.
Yeah, sir, you talked about. Am I audible, sir?
Yes,
yes.
Yeah, sir, you talked about different distance metric. How do we decide like which metric is suitable for which algorithm? Like, because apart from this, even Mahalanobis distance is considered in some of the algorithms.
Yes. There are a lot of distances, but for example, if I am looking at energy, I want to separate objects which have low energy to high energy. Euclidean distance makes sense because the energy of a signal is simply square root of the squares of the data points, right? Yeah. Euclidean distance is same as energy, okay? So you must be very clear what distance makes sense. For example, I'm looking at distances of traversing in a city. I must use L1, that is absolute sum, not the hypotenuse, because no vehicle can go on the hypotenuse. All the roads are rectangularly demarked. So x1 plus x2, mod x1 plus mod x2 will be the correct answer. Similarly, here Chebyshev norm, you want two things, you want to solve for the maxima or minima, whatever you want to do. So if you are looking at really sensitive metrics, you must know in the domain what kind of distance makes effectiveness. So it's not a open and shut kind of question. The domain knowledge, the domain features, the domain sensitivity, we decide which metric will be more useful for you. But Janta problems, L1, L2, L infinity, standard. Because you want to work with millions of data points and stuff like that. So that's an unsolved problem, but only domain knowledge, somebody will tweak some other distance and let us know. Okay?
Right, sir. Thank you, sir.
Any question?
Anyone else? Okay. Thank you, sir, for such a highly informative session on machine learning. So, dear participants, feedback link, attendance link is shared in the chat box. Kindly give the attendance for the morning session. Now we shall break for lunch and resume the afternoon session at sharp 2 p.m.
Now we'll do it at 1:50.
Okay, sir.
1:50 we will try because I want to make sure that everything is
okay.
there.
Okay, sir.
We will start sessions at 2, but I want to log in at 1:50. Okay.
Okay, sir. Fine, sir.
Can I unlog and then log in once more, or the link will go away?
No. Same link will be used, sir.
Okay, fine. Thank you.
Okay, thank you, sir.
Thank you, all of you.
Thank you.
Thank you, sir.